The Earth, like everything else, is comprised of matter. So what would you do if it were to suddenly disappear? Well, you'd be a little confused because it doesn't make sense, and the law of the conservation of matter says heck no. Let's say you have a square. It could be a green square, but it doesn't really matter. You wouldn't expect the square to just suddenly turn into nothing. The square could be cut into 4 separate pieces, all squares, or it could be cut into 2 triangles. But regardless of how you cut it, it's the same square. Let's apply this principle to the Earth and the various elements that it contains. These elements comprise all of matter, which lends itself to a pretty vast area of study. We measure their reactions to each other in a field of chemistry called stoichiometry. Let's take a look at this molecule. It's water. It's made up of 2 hydrogen atoms and 1 oxygen atom. Hydrogen is a diatomic gas, meaning that 2 alike tend to bond together. But so is oxygen. And yet, if you split a water molecule into the atoms that comprise it, you will arrive at 2 hydrogen atoms and 1 oxygen atom. So, where is the balance in the stoichiometric universe? Let's take a look at the equation of the reaction. Hydrogen gas plus oxygen gas equals H2O, also known as water. But you may notice something peculiar now. There are 2 oxygen atoms to begin with, and only 1 in the product. The magic lies in the ratio between the atoms of hydrogen and the atoms of oxygen in the equation. Every single quantity of pure water will have 2 hydrogen atoms for every 1 oxygen atom. We can apply this to the balancing of stoichiometric reactions by placing coefficients in front of atoms or molecules. Multiply the value of atoms within a molecule by the coefficient and balance with the other side of the equation. In the end, the ratio of the reactants will be the same as the starting ratio of the product. In this case, the reactants are balanced to 4 hydrogen atoms to every 2 oxygen atoms, a ratio that can be simplified to say 2 to 1.